This is Dr. K. Rajendra Prasad, working as a professor and head of the Department of CAC Cyber Security at Institute of Aeronautical Engineering, Hyderabad, Telangana. So my subject introduction is compiler design. Here I am going to cover the first topic is introduction to compilers. Prior to the compiler design, we first know the prerequisite of theory of computation. The theory of computation, everyone having the idea about finite automata and other related concepts like scanners, parsers, ambiguity, grammars, and everything. So automatas are very useful. So with the help of automatas only, we are knowing to that construct the compilers. So theory of computation is the prerequisite subject of the compiler design. So here, at the end of the course, at the end of the compiler design course, students should be able to learn the following course outcomes. So I will explain the what are the important outcomes of compiler design. So in the first course outcome is the student know that what are the key phases of the compiler and construction of the language processor. With the help of the phases of the compiler only, the student able to know what is the basic idea of language processor. The second one is finite automata. How the finite automata are very useful for the compiler constructions. So that outcome we have covered in the compiler design, that is CO2. Make use of finite automata for designing a lexical analyzer for a specific programming language constructs. Third outcome is in the compiler design. So the very important thing is parsers. So we should follow the total for two designing of parsers, top down and bottom up parsers. With the help of the parsers and the parsing tables, so we have to verify the syntaxes of the various programming language construction statements. So that is covered in another model. So with that model, we achieve the third outcome is CO3. So CO3 outcome is choose top-down, bottom-up parsing methods for developing a parser with representation of a parse table or tree. So after verifying the syntax of the program language statements, then the language statement that can be converted into some intermediate forms. Here we use some various concepts, quadruples, triples, infinite triples, syntax tree, etc. So that information is covered in the fourth model. From the fourth model, so the students able to know another outcome is CO4. So this outcome is outline syntactic translations, intermediate forms for performing semantic analysis along with the code generation. So after knowing this intermediate code, different forms like quadruples, triples, and everything, next we have to go for very important thing is so how the information will be stored and what are the different storage mechanisms are used. So therefore storage different storage mechanisms, how can you use efficiently. So with that idea, we have to achieving the another course outcome is CO5. So CO5 it explains relate to signal table, type checking, and storage allocation strategies used in runtime environment. Another outcome is last outcome is CO6. So after the compiler design, so last phase is very important regarding the code optimization. So how you will be optimize the code. So after completion of this entire course, the student is able to know so how can apply the different code optimization techniques so that the code becomes faster and the code that will be stored during the execution or during the compilation in the memory. How can you use the memories efficiently? You know all things. So that we have to achieve the last outcome is CO6. Select code optimization techniques on intermediate code form for generating a target code. Now I'm going to introduce the compilers. So basically, what are the compilers? So compilers are nothing but different language processes. So you want to process the language. So what do you mean of language processing is? So suppose any user written the program in the form of the source language nothing but in the form of natural English language that cannot be understandable by the mission. So that's why some kind of processing is required, some kind of language processing is required that comes with some kind of translators. So means the idea of converting the source language to mission understandable code. That idea is called as language processing. So for the language processing, we use the compilers. So the compiler duty is it acts as a translator. So compiler that can read the source program and it converts the source program into some mission understandable code, or it converts the source program into some target program. So that is the idea of compiler. So the definition of the compiler, so that we have to follow like this: compiler that can read a program in one language, source language, and translate it into equivalent mission understandable language. So here, what is the role of the compiler? So compiler role is very important because of it cannot directly translate the code into mission understandable code or object code. Before translating, it can also verify the what are the errors in the program. Means the user is due to some typographical errors or due to unaware of any particular instructions. So he written the program is with any syntax errors that can be detected during the compilation. So that can be performed by the compilers only. So the role of the compiler nothing but it reports any error in the source program that it detects during the compilation or translation process. So means before generating the target code only, the compiler will verify the source program. In the source program, all instructions that can be typed by the user itself only. So all the instructions are they typed by the user in the appropriate manner, nothing but grammatically or syntactically or semantically. Everything is correct. Then it shows no errors. Then only it can generate the target code. Means compiler generates the target code when nothing but there are no errors in the program. Suppose if there is any errors in the program, the target code cannot be generated by the compiler. So means the main role of the compiler is it detects the errors during the compilation process, that is during the conversion process from source program to object code. So when you getting the object code or when you getting the target number, if there are no errors, then only target code is generated. So it is the role of the compiler. So we can say in the online statement what the role of the compiler is. It detects the errors during the compilation process. So we have to see the source program, how the source program, how the source program, okay, that can be converted into the finally target program. With the help of the compiler only, it is possible. So compiler nothing but it becomes as a translator. It translating the source program to target program. When nothing but no errors in the program. Suppose there are errors in the program, okay, it cannot generate the target program. So we have to see what is the use of the target program is. Target program, it may be understandable by the mission code. So then once the mission is understandable, then it generates the your user expected output. So these two figures explaining the role of the compiler. We see another language processor. We have seen in the last in the earlier slide one language processor is compiler. So another language processor is interpreter. So interpreter is another different kind of language processor. Come to the functionality point of view, compiler functionality is different and interpreter functionality is different. The compiler functionality is it compiles the program, entire program, whatever number of lines are given, it compiles the entire program at a time. But in the interpreter, it is not like that. Interpreter interprets the instructions one by one only. It cannot interpret the entire program at a time. So this is the process of interpreter. So means using the interpreter, you're trying to detect the errors instruction by instruction. Suppose, for example, in the source program, totally for 10 lines are given. In the compiler, you have to go for all 10 lines compiled at a time. But in the using the interpreter, it will verify the instruction one, verify the second instruction, verify the third instruction, like this. Means using the interpreter, you cannot getting the idea of the errors. So for the entire program at a time. Using the compilers only it is possible. So but so you want to find where is error correctly, where is error exactly. Means you want to find the exact error at what place. At that time, interpreter is very useful. Using the compilers, suppose any error is found, where is the error and what the reason? So what instruction has the error? So detection of that kind of idea is very difficult using the compilers. So you want to know you want to know the error exactly at which line. At that time only you are using the interpreter. So one more thing is it cannot be generate any target program as a translation. This is another idea of interpreter. So it directly execute the instruction by instruction in the source program. So here I am showing the diagram of the interpreter is source program is given, input is given, and what the interpreter is. Interpreter nothing but it will check instruction by instruction in the entire program. Suppose no errors, finally generating the output. Here there is no, I think, target program. But target program, so you have to check in the previous slide what happens after that. Here target program is generated. But there is no such type of target program, generation of target program in the interpreter. So directly source program is taken and input nothing but what are the values you require, you are getting that data from the user itself only or from some other external sources only. That's the input data. So after taking the input data and you have to go for instruction by instruction. First instruction if it is okay, then you go for second instruction. Suppose if any error is found at second instruction, you cannot proceed the remaining third instruction to 10th instructions. So that is the idea of interpreter. Means once you completed all these instructions, verification means some syntactically or semantically. Okay, what suppose there are no errors are found during the verification of instructions one by the interpreter. So finally, you are concluding that I think you are expecting next step is the idea for output. Means here there is no target program. Means where the target program is generated. So in the compiler, okay, you are not expecting the target program, but in the interpreter, you are not expecting the target program. So once the instructions are completed, instruction verification is completed one by the interpreter, directly you have to getting the output only. So here I am listing the some key differences of the compilers and interpreters. Compilers nothing but I think you know the idea. It is some kind of translator. It translates the entire source program to target program. But interpreter, I think it is not a translator. You're not expecting any target program. Just interpret the instructions one by one in the given source program by the user. There is a key difference. The second difference is it shows the errors after the compilation process. But here, in the user interpreter, you cannot interpret the entire program at a time. You are verifying the errors verification one by one only, line by line only, line by line instructions only in the source program. The third key difference is it compiles the entire program at a time, but you are not expecting here in the interpreter. So it compiles the entire program at a time using the compiler, so that definitely compilers are very faster than interpreter. But you come to the fastness point of view, interpreter are very slow. But here you are getting the better error diagnostic than a compiler, because of suppose 100 lines of program are there. So here, so where is the error? At which line of code is very difficult using the compiler. But in the interpreter, the duty is mainly you go for line by line verification only. So the error diagnosis, I think here you are getting the better idea using interpreter than a compiler. So these are the key difference between the compilers and interpreters. So now in real time, we are using the many number of high level languages and some other middle level languages also. So from the language point of view, nowadays mostly the users are interacting. These are the different languages: C language, C language, and Java. What is C compiler? I'm giving the question is for the C compiler. Means nothing but so is it C language for processing the C language? For processing nothing but compilation and execution. So the entire compilation execution of the C language. So that case you need some language processor. Better thing is we use compiler. We use compiler. So compilers initially it convert the source program of the C language that can be converted into some target program, that is obj file. .obj file means any source program is there that can be converted into .obj. So then you try to make a execution of this OBC file because of OBC that can be understandable by the machine. Okay, machine generated code. So now this is called as a target code. This is called as a target code. So that is the idea of the compiler. Just we come to how the idea is. Another is the C double base language. Here also we use compilers. Yes, it is true. It is also true. C double base also, I think that language, you want to process that language, process nothing but you want to execute the C double base program. Here also we follow the same thing. Source program that can be converted into the .obj file. And another idea is the interpreter. Interpreter idea is different. Okay, we have to go for I think interpreter the better idea in the Java programming language. But interpreting the program, C developers program is also possible. In the case of debugging, most probably you have to see that kind of simulation of the interpreter in both C and C developers. But what happens in the Java nothing but Java, I think it may be used or it has used both compilers and also interpreter and also interpreter. Yes, we have to say. But here we use the only for compilers only. C is compilers only. C is also compilers. But Java it uses both compiler and also interpreter. That is the difference between the these languages. When C and C plus you come to see you come to say about compilers only. But where we exactly use the interpreter and compiler nothing but in the Java programming language. So the explanation is we have just coming slide. Okay, this slide will give the complete idea how it combines the compilation interpreter. You have to see the diagram is like this. So here initially as per the compiler, what is the knowledge you got nothing but the given source program that can be converted into some target program. Here it is called as target program TP. TP nothing but target program. This target program that can be the format is intermediate code form, or it is also called in your words the Java language bytecode. It is also called as bytecode, and everyone is knowing the bytecode. Means initially you written the Java program in the using the some source form nothing but using some natural English language as per the grammatical syntax of the Java. Whatever you follow input and output statement and any control statement you follow the syntax of the Java. But you return using the language form is the natural English language. That's a source language. That is the human understandable language. But a machine cannot understand that one. So we use the compiler, Java compiler. So the duty of the Java compiler is it translate the source program to intermediate program. We have to see this intermediate program. This is a target program. So here what the target program format is a bytecode. Bytecode. Next you have to go for using the interpreter. So you have to interpret the instructions from the bytecode, and you have to getting the input also from external sources. Then finally you have to go to display the output. Means here we have to verify that I'm adding the plus symbol, nothing but you make use of both the translator and also interpreter. So means when you use the interpreter, so you have to use the some in the case of Java virtual machine, you use the Java interpreter. So Java interpreter, what happens the thing that it interprets the code, it interprets the byte code, and it takes the input data. Finally, try to generating the output value. So this is happening in the case of Java language processor. So finally, you have to see one final look is about language processing system. What happens about the language processing system is so this is a common format you have to observe in the language processing system. As per your understanding, initially you take the input in what format is source program format only. So the source program format that may be for single program, or it may be any number of n number of models also. In number of models or units. The source program that have in the form is n number of models or units that can be individually collected by the some preprocessor. What do you mean of preprocessor is that? So preprocessor nothing but that can be used to expand the shortends. I will the name is shortends, or in your technical terminology's point of view, macros. It's also called as macros. Shortends or macros. So preprocessor it can use shortends or macros. Then we call the corresponding model or unit of the source language that can be converted into another form is the modified source program format. So means any library file or you want to create your own function, your own user defined function, you call with some macros. For example, is the C program, hash define statement is there. Using the hash define statement, you define the any function also, or you call the some variable value also. Suppose I am using the function is the hash define pi 3.14. It is a constant value. No? So means this call as macros, or you may call any variable value or any function. You can call either for the preprocessor. So means you should elaborate what about the value of the variable or the code of the particular model that can be converted into the source code into modified source program by the preprocessor. That is the first step you have to observe. And next one is the compiler. You know the compiler is that can be directly converted into your expected target program. Here I'm using the word is mission understandable. What mission understandable? Any low level language. For example, I am taking the here low level language is assembly language. So your source code that can be converted into target mission understandable code is low level language is assembly program. But assembly program directly it is not compatible with the mission. It is a low level language only, not complete mission understandable language form. So you can make use of the assembler. Assembler also some kind of translator, some kind of language processor that can be converted into the some mission understandable code that is called as relocatable code. So finally you make your relocatable code, and at the same time you want to execute any particular functions. The functions are not available in your source code, that is available in another header file. You may link with that but some other relocatable mission code using the linkers. So means so these are the steps generally how to follow in any language processing system. It may be applicable for any particular language, C language, C double plus or Java, any kind of language, you follow the same thing. So in this, what happens? What are the key steps you have to follow is the first key step is initially the source program is given only in the form of shortends only or macros only. You need to elaborate that what is the code of the macro, what is the variable value for that particular macro. So that can be processed by the some preprocessor. So preprocessor do the thing is convert the source program into modified source program. So what is the source program? What is the modified source program? Source program it includes some macros. So under particular macro, the code is there that's somewhere. So you want to expand that code, okay? Then you can make use of the preprocessor. You can modify it into some other source code. The compilers do the thing is convert that modified source code to target program. Here I am taking the example is not for directly mission understandable. Some kind of low level language. Low level language is better than high level language from mission point of view. Is very near to mission from understanding point of view. That's why here I am using the some assemblers. The assembler that can be converted the target assembly language program to some mission understandable code that's called as a relocatable mission code. So that relocatable mission code it wants to some other functions. The functions are available in some other header files. The header files also have some other relocatable mission code form that will be linked using the linkers. Means you have to load whatever you required. We have load that thing in the main memory. Again, you have to make a link of your relocatable mission code to some other relocatable mission code. So finally, you are trying to generating the target mission code. So this is, I think, idea about the diagnosis processing system. Later, we have to see the phase of the compiler. So these are the very important things for designing the before designing the compiler. You must know what are the important phase of the compiler. So I am coming to that one by one. Lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, vision independent code optimization, code generator, vision dependent code optimizer. So these are the important phases of the compiler. First, we have to see lexical analyzer. What do you mean of lexical analyzer? User is written the code in terms of number of lines. Each line of the code consists of some number of tokens. Token nothing but what the basic idea is the individual unit. Each token we have to call as also lexi. It's called as lexi. So I have an underlining here is called as lexi. So lexi nothing but token or individual unit. For example, you have to take this example A equal to B plus C. What are the lexims are nothing but, or what are the tokens are nothing but, A is one token, equal is another token, B is another token, plus is another token, C also one more token. Means whatever statement is given in the code by the user, initially the compiler will make use of that phase is called as the lexical analyzer phase. The role of the lexical analyzer is it convert or it can separate the given statement into some number of individual tokens, a number of lexims. Token nothing but some individual unit. We try to understand with this example, so how the lexical analyzer will separate the all things. But here we should follow one important thing is in every token not have the value. Only for some of the tokens have the value. We have to see that A is a variable. It may be have the some value that can be obtained after computation of the addition of two numbers B plus C. But what is the equal is? Equal is just for the operator only. No value. No value. I am saying here no value. No B, but no value. B it may be value. What is the plus is? It also no value. C is maybe have the value. They also have the value. So we have to see that finally which tokens or which lexims have the values are A, B, and C only. And what are the some of things are assignment operator and also plus operator. For these cases, no values. For these cases, no value. Okay, these three are the values. So we have to see that read the stream of characters. Whatever statement given, from that you have to read what is the stream of characters, making up source program and groups the characters into meaningful sequences called as the lexims. So means here you cannot go for separating like this. A equal. Okay, how to separating? A is separate, equal also separate. So means we have to dividing the given statement, given line, given instruction of the particular program language into some number of lexims. Okay, as per we have to follow the some meaningful nothing but. So you cannot go for the variable. Suppose I'm saying A B equal to C plus B. Here you take the AB is considered totally considered one identifier. As per the identifier rule, you know that AB is totally considered one variable. So it means for this the individual tokens are AB is one token, equal is one token, C is another token, S is another token, D also another token. So like that we have to divide the program language statement into meaningful units, meaningful lexims. That is the beauty of the lexical analyzer. So we have to see the the syntax of the particular lexeme is like this. The lexeme has the total for two values. What are the values are? Token name and also attribute value. Token name and also attribute value. The attribute value that can be stored in the symbol table means create that we have to assuming some symbol table. I'll explain later what the symbol table is. In that we have to store the values. Okay, suppose A value is 2, B value is 3, C value is 4. They are also stored. These locations are called as the first location you are assuming. This is the second location. This is the third location. Now we have to go for what the token name is. For example, here token name is A. This is as per token name, comma. We have to put the what the attribute values. Attribute value is 2. That is there. The 2 value is there at which entry of the symbol table. Entry number is 1. Entry number is 1. Like that, one more is suppose B is there. At what entry is the B values? You know the 3. But 3 is appear at what entry of the symbol table is 2. Like that, you have to understanding A, 1 equal to B, 2, C, 3. Means at one first entry of the symbol table, what the value is there, you can retrieve here, you can substitute, okay, and getting the one result. So like that, you are assuming, okay, of course here I am giving 7, no? A is 7, A is 7, you get A is 7. So like that, we are assuming, okay. So what is the token name? What is the attribute value is? So many other examples also given here. So here no symbol table entries for, you should remember one more important point is no symbol table entries for operators or relation operators or boolean operators or assignment operators also. You should remember. Here we have to go for another example. Which are having the symbol table entries C, the variable C, A, B and also C. These are having the symbol table entries. No entries for which operators are equal, plus, multiplication. Okay, these three cases no symbol table entries. Only here we have the symbol table entries. You see this example case, how can you analyze? For example, I'm giving the statement is C, 4, which is equal to A, 3 or A, 1 plus B, B, 2 into C, 3. So I'm giving the symbol table example is here. A, B, C. You see that this entry is 1, this entry is 2, this entry is 3. Okay, again finally the result of C is another entry is here 4. So we have tried to assume this entry is 1 in the symbol table. The value of the B is stored in the symbol table at what entry is 2. The value of the C in the symbol table, it is stored in the third entry of the symbol table. Finally the result of the C that can be stored at what location is the fourth entry of the symbol table as per. So here equal symbol, no entry, no symbol entry, only variables here. A, this is the A value, this is the B value, this is the C value, this is the resulting C value. Okay, here we cannot assign the location for operators, so that's why this is the assignment operator, equal also assignment operator, multiplication. For these cases, no entries, no symbol table entries. You should remember. So this is the idea of lexical analyzer. So lexical analyzer will do this particular statement of C equal to A plus B into C into different lexemes. What are the lexemes here? C is one lexeme, A is lexeme, B is lexeme, C is another lexeme. These lexemes have symbol table entries. Some of the lexemes also there along with this particular statement, equal, plus and asterisk operators. So these also consider lexemes but no symbol table entry. So here we have to given another example, third example, similar try to solve this example, which are having the symbol abilities. Put the tick marks, which are not having the symbol abilities. These operators. These also 60 also have this symbol ability. The value of 60 is stored in somewhere. Okay. So with this, today we conclude the topic of introduction to compilers. Here we covered definition of the compiler, what is the interpreter, what are the differences between the interpreter and the compilers, what are the language processing system, how to analyze the language processing system, and then you go for one more idea is phase of the compiler. In the phase of compiler, we have to interact with this class, lexical analyzer phase. So what the duty of the lexical analyzer phase? And in the lexims, which tokens having the symbol table entries, which tokens not having the symbol table entries. So we have to got some clarification in this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.